right, here we're going to go through section 1 in chapter 2. And in this section, we're really going to be talking about functions. So here we're looking at some of the objectives for today. So we're going to really figure out if a relation is a function and finding that value. Then we're going to look at something kind of funky that you'll use in calculus, which is finding the difference quotient. Then we're really going to be finding the sum, difference, product, and quotient of two different functions. So the first thing we're going to do is determine whether a relation represents a function. So here we can see a line. We've just got this linear equation with these 2 points given on it. So we want to figure out if this represents a function. So we need to know what a function actually is. So a function, and this is in your notes, that a function, and I always abbreviate function as fxn. So a function is where every x has only, and that's the big point, only one y value. So we can look at that in a table or a graph or really anything. So in this, what I see is that for every x value I have, right, so I can go along the x-axis any direction, I have only one place where I touch the graph. So that tells me that this would in fact be a function. So I can also see this as a table, and it doesn't always have to be numbers, it could just be data points too. So here I can see I've got my x values, right, my input, and I've got my output values. So a function tells me that every input has only one output. And here I can see that there's only one arrow coming off of each input. It doesn't matter where they go to, I just see that there's one from everything. So that also tells me that that is a function. So here for a difference, there's two different arrows coming off of this input, this person Colleen. So since there are two different arrows coming off of here, that tells me that this one is not a function. So that's kind of our difference there. Okay, so here's our actual definition. So x and y are two non-empty sets, just meaning there's stuff in both of them. So a function tells me that there's exactly one y for each x. That's the important part, the exactly one value. So we can see that as well. So what we also see is that our domain is our x values. Domain is our possible x values that would work. And our range is then our possible outcomes or our possible y values. So not everything is in our range, right? So domain just tells me I plug these things. These are the things that I can plug in as x. And the range is the things that I get out once I do that. Okay. So for here, we're going to look at C. So we're going to see that the relation is right here. And I can see that this one is not a function, right? Because this one has two arrows coming off of this 0.71. So that's usually going to be the first question you answer is is this a function? And for this one, it is not, since that there's two arrows coming off of that. This x value has more than one output. So here we're also going to find the domain and range. So for this figure 8, we're looking here at C. So my domain was all of my input values, and my range was all of my output values. So I can just take that from the different squares that I'm given. Here's all of the inputs, and here's all of the outputs. So then, like we said, it is not a function because there's more than one output for that one of those inputs. Okay, so that can also happen here given some numbers. So for this example B, I see I've got 1, 4, 2, 4, 3, 5, 6, 10. So I look at my inputs first. So I look at 1, 2, 3, and 6, and I see I don't have anything that repeats. So I would say that yes, this one is a function. So for this C though, I see I've got this -3 here and this -3 here. Well, those each have something different, so this one would not be a function, just because of those different values. So now we're going to look at finding the value of a function. So when I do that, when I'm finding the value, or it's called evaluating a function, we can also see it as something like if I take f of 3, this tells me the thing that I put into my function, and it will come out as my answer. So input is the thing that's in those parentheses, and this is the output, what I will get from that. Okay, so a function operates just kind of like a machine. When I input something, I get one thing out. So let's look at just one of these examples. So here's my function right here, and I'm asked to evaluate it at these different places. So here I see I have a 3 inside those parentheses. So that tells me everywhere there was an x, I go ahead and I plug in a 3. And I evaluate it, and then I can go from there. And here you're going to work on several different types because you'll see you've got different things both inside and outside the parentheses. And so it's really just looking at how you're going to be dealing with these functions. So you see for that first one, we just substitute that 3 in, just like we said, wherever there was an x, and we can get to where it's 9. Well, sometimes, like in example B, you see I don't have a number, so I don't actually change anything there. Okay, so here's this difference quotient, what I said was going to be kind of funky. So here's the difference quotient, and this is just our example, and we're going to just be plugging things into here. So what we're going to do is we are really going to look through A, and this is the piece that you have in your notes as well, is this first part. So I'm going to use that function, and we're going to find the difference quotient. So what we go ahead and do is we take our just equation for our difference quotient. Anywhere in my equation where there was an x, I go ahead and I put this x plus h. And then this just f of x, that's my just normal function that I was given. So you'll see here, is this first part. That was my function where I plugged in this x plus h anywhere there was an x. This part that I'm doing in green right here, this was just my normal function that I started with. So then I can go ahead and expand my exponent. Then I combine like terms and I simplify. So then I just keep doing that. So once I'm down to this term, this line right here, I see that every single piece has an h in it. So I go ahead and I factor that h out. Because when I factor that h out, I can cancel it with the denominator. And so then I'm just left with a 4x plus 2h minus 3. So this will all start to make way more sense when we get to calculus, because this is how we find the derivative, like when we start differentiating our equations and finding our slopes again. So this will come in handy later. Just I want you to know that we're really just plugging in this x plus h wherever there was an x before and kind of just simplifying from there. So now we're going to look at the domain of these functions. And I want to start by looking at these kind of rules. And these we should have in our notes too. So the first, we want to assume that the domain is all real numbers. And then we can look at some things that exclude. So if I have a denominator, anything that makes the denominator 0, that is not part of my domain. So we exclude that piece. Also, if I have a radical, so like the square root, any number that makes that negative also gets kicked out of our domain. So you'll see a couple of examples up here if you want to pause this video or look through. These are the examples in your book that you can walk through as well. Okay, so here we're going to find the sum, difference, product, and quotient, right? We're just adding, subtracting, multiplying, and dividing two different functions. And this is exactly what I put in your notes. So there's our different definitions. So then we're going to use these two functions and do those. And that's what I did in our notes, is first I add the functions together. And since these are both rational functions, meaning kind of fractions, I first have to find a common denominator, just like I did with simple fractions, before I can actually add them. Once we get to this piece right here, we can just leave it like this. We do not have to simplify it any further. So we can see too that we also have to specify our domain. So we want to say that the domain is the set of x values such that x does not equal -2 and x does not equal 1, because both of those values would make my denominator 0. So here again, you'll see that we're subtracting those two functions. And again, I have to find that common denominator before I can do that. And then again, we multiply and divide. But when I multiply fractions, I can just multiply straight across. And when you're doing these different operations with functions, it's really important to remember what kind of function you're dealing with and what specific things need to happen with that. So that's really all there is for section 2.1, is we're really just dealing with these functions and evaluating them and then adding, subtracting, multiplying, dividing. So now make sure that you feel a little bit more comfortable. If you want to walk through some more examples, we can certainly find some more. But now you definitely want to go ahead and work on that homework and see if you can make it all the way through.